Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 109. The topic is the Federation Challenges of BlueSky and Mastadon. Quick reminder, support the live stream. Please follow us on LinkedIn. Our guest today is Aaron Parecki, Director of Identity Standards at Okta, co-chair of the OpenID IPSI Working Group, prolific OAuth contributor. Welcome, Aaron.
Thanks for having me.
So today we're going to skip the intro because Aaron is a returning Identity. If you want to hear his backstory and how he got into identity, just go to the beginning of episode 15. And we're just going to use all the time available and dive right into it. Aaron, I've been super excited to talk about this topic since I attended FOSDEM in Brussels this past February. And I had the luck of sitting next to Renaud Chaput for the CTO of Mastadon. And he was telling me about some of the interesting challenges they were having around, retweeting other people's, tweets, or I don't know if that's the right word, reposting other people's posts in this world where you have not one central server, but a federated servers that need to talk to each other and trust each other. And I quickly realized he really had some interesting challenges. And he said he was talking to this identity expert named Aaron Parecki. And I was like, oh, well, you have the right guy on your team to help. And then I reached out to you to talk more about it. And here we are. I'm an avid LinkedIn user, as everyone knows. But I'm not so much of I signed up for BlueSky. I haven't, I'm not a user of Mastodon, but I think you have slightly more experience than me in this area. Maybe we could start, Aaron, just by talking about, as a user, sort of what's the difference between having a BlueSky account and a Mastodon account?
Yeah, there's a lot of different ways you can go with that, but let me just focus on a couple aspects of it. So first of all, you can find my BlueSky at aaronpk.com. That's my BlueSky handle. It's my own domain. My Mastodon is actually not a Mastodon. It is my own server that speaks ActivityPub, which Mastodon uses to federate. So I did a lot of implementation on this a long time ago to just build it sort of into my website. So you can follow me from Mastodon, aaronparecki.com/aaronpk, or aaronpk at aaronparecki.com is the Mastodon way of doing it. So yeah, I'm a big believer of owning my identity online as I'm using it to communicate with people. I do have a LinkedIn, of course, but whenever I post on LinkedIn, the post is actually first from my website, and then I manually copy it to LinkedIn since I can't use their API. But that's also how I treat BlueSky and Mastodon, where everything is actually originating on my website, and then it'll get sort of copied to BlueSky, and it's not copied to Mastodon because my website can be followed from Mastodon. But anyway, long story short, the sort of difference and the thing that's going to tie into what we're going to talk about in a minute here is more on the portability of the identity in between Mastodon and BlueSky. So with BlueSky, my identity there is aaronpk.com. Like, that's what you would search for. That's what you would tag in a post. That domain is really just a alias for the actual identifier in the BlueSky network, which then ultimately resolves to a server that my data lives on. That server I don't run. I use the BlueSky hosted server like most people. I don't really have the interest or time to build my own BlueSky actual server, but I appreciate being able to take my domain and just point it to the BlueSky server, just like you would do web hosting, right? Like, obviously, like, not everybody needs to write an HTTP server in order to have a website. You take a domain and you point it to a web host, right? So that's the BlueSky model, and I think that makes a ton of sense. With Mastodon, it's completely different. With Mastodon, your identity on the network is tied to the server. So my identity on Mastodon is aaronpk at aaronparecki.com, and that's because I have a code on my web server that speaks ActivityPub. Most people don't do that. I don't recommend it, actually. So if you are using Mastodon itself, then you have picked a server, or maybe you are running your own copy of Mastodon on a web server, but your identity is then tied to that server. So you'd be username at server, and you can't really move it around. There is a way to like forward your account to another server if you want to actually change servers, but it's not the same identity. It only works if your old server is online still. There's a bunch of caveats with it all there. So I I think it's one of the limitations of the Mastodon model in general, is like you can't really delegate your identity in the same way. So anyway, those are some of the differences between the two, at least from um, the identity aspect of it.
Could you say that Mastodon, or I'm sorry, BlueSky is more like your domain registrar, um, which is sort of knows where your site lives and then says, okay, well this name for this lives here, so this is where you can get it on BlueSky. I don't know. Is that an apt metaphor?
I mean, I wouldn't say the BlueSky network is like a domain registrar, but yeah, it's the whole thing works more similar to how domain registrars work. Of you get a DNS name, you put a DNS entry on it. In the web server case, it's like pointing to the IP address of the server. In the BlueSky case, it's pointing to the record of the actual BlueSky identifier. So it's very similar in that sense. What it means is that if you want to have your own custom handle on BlueSky, the lift is very low compared to having your own custom handle on Mastodon or
Hmm.
ActivityPub in general.
Okay. So let me actually talk a little bit about the use case that Renaud raised, which had to do with if I'm a user on my domain and I repost somebody else's um, content, then I guess the home server the person whose post I've promoted, like their number of tweets has to go up by one, right? So they want to know about it, and then ideally, like this post has to get distributed to different people's feeds around, which means that the servers sort of need to talk to each other, um, and so this raised questions about um, let's say, okay, so we could do dynamic client registration to automate how one client could maybe call the API of another server. Um, but then there are issues with duplication of clients and client lifetimes. For example, if I have a bunch of users on my servers and I keep reposting on your server, I would want to have ideally just one client for my domain to your domain, not one client for every single person who reposts.
Well,
So,
there's actually two separate things you're talking about here, and they're different problems. So the way that the servers send the posts between each other actually
mhm,
has nothing to do with the client registration problem. That's the server-to-server federation, and that is described in the ActivityPub protocol. There are some interesting challenges there for sure, especially around like how does a brand new server find out about old posts from a user and things like that. The client registration problem, though, is entirely about the client to server interaction, which is mostly about when a user like downloads a mobile app and logs into their server
mhm,
and uses their app to post to their server. So
yeah.
that's where the client registration question comes into play.
Interesting. So Blue Sky has actually put out quite a extensive profile of using OAuth to achieve this federation. And I was reading through their technical document, and they made some really interesting design choices. And I just wanted to raise a couple of them. And the first one is like this is something that I've been saying for so long that seems like somebody finally did something about. But the client ID is a fully qualified web URL pointing to the metadata of the client, and there's no client secret. Um, but can you talk a little bit about that one, why that was needed, and why that might be a good idea?
Yeah, so let me back up and first start with a little bit of background on OAuth in general. So in OAuth, the idea is there is some piece of client software that needs to talk to an API. And in order to do that, it's going to need to get an access token so that the API request can include the access token. It's going to, at least certainly in the case that we're talking about here, involve getting a user to log into that application, which means that access token is has that user's context in it, so that the API knows which user is making the request. So all of that process of like getting user to log in, getting a token issued is an OAuth flow, and the most common OAuth flow is the authorization code flow, and in the flow, there is the need to identify which piece of software is making that request. So that, and there's a number of different reasons to identify the software, anything from knowing what icon to show on the screen that says, do you want this app to be able to post to your account, to things like actually doing client authentication, where you can have some more, where the server can have some more assurance about what software that is. There's a lot of different reasons to need to know about the client. And that's the thing that we're talking about here. So the key thing that makes BlueSky and Mastodon different than most traditional OAuth deployments is that for the last 15 or more years, most of OAuth is deployed in centralized systems, I guess, for the lack of a better word.
Like Google.
So, like Google, like you want to do sign in with Google. Well, as a developer of an app that's going to use sign in with Google, you have to go to the Google website. You have to sign up for a developer account. You have to go create a client. Creating a client involves typing in the name of your client, uploading a logo, a bunch of other stuff. And now it's even more complicated of agreeing to terms of service and going through certifications, blah, blah, blah. The result of that is that Google issues you a client ID and client secret. And that pattern is extremely common. You'll see this on like GitHub. You go to the developer website of GitHub, you register a client, GitHub gives you a client ID and secret. And then as the developer, you're writing in the app and you can use that client ID in the request. So it's fine. Like it works fine for those models where there is a server that a developer is trying to use.
And that client ID is normally a string with sufficient entropy.
Yeah, it doesn't even really matter. It just needs to be a unique string within that server. So it's not like it needs to be globally unique. It doesn't need to be, it's not a secret, so it doesn't need to be a certain length or anything. It's just like some client IDs are like 12 letters long, right? Like it doesn't really matter.
Okay, if they manage it, as long as it's unique, it's fine.
Exactly. So like with GitHub, for example, like GitHub needs to make sure that they don't issue duplicate client IDs. But no, if Google has a client with the same client IDs random string that GitHub does, it doesn't matter because there's no overlap, right? So it's just unique within that authorization server. And yeah, that model works fine for that. So, but again, the key thing that makes it okay is that the developer has the relationship with the authorization server that they're using. As in, as a developer, I've gone to the GitHub website, I have an account, I've registered a client, I get a client ID. So that's how OAuth has been traditionally deployed. The thing that makes BlueSky and Mastodon different is that premise does not exist. As in, anybody can write a Mastodon client and anybody can write a BlueSky client. And then the users who are using those clients have servers that the client developer doesn't know about. And it's the same with like WordPress, right? WordPress is open source software. Anybody can install it on their server, which means any WordPress applications, by definition, can't know about all WordPress servers. So the same with Mastodon and BlueSky. The premise is that if I want to go write the best new Mastodon app, I can go write a bunch of code, put it in the App Store, and then anybody can download it. And the first thing that the user has to do is tell the app where their server is, which means as a developer, obviously I can't go around and register client IDs on every Mastodon server. Like the concept just doesn't make any sense, right? So that's the key difference here, is that there's X number of clients over here and there's Y number of servers over here, and they don't know about each other on either side ahead of time.
Yeah. Right. Okay. So I thought it was more inter-server communication, but it sounds like the issue is more Like somebody downloads a client on their mobile app on the App Store, for example, and that client needs an identity. Um,
Yeah.
Interesting.
So yeah, so the first thing that the user does after they download the Mastodon app is they type in the URL to their server, right?
Yeah.
And that way the app knows which server to use to make API requests to. So now we can talk about the OAuth part because
Okay.
the obviously that client application needs an access token to that user's server. So this is where Mastodon and BlueSky have done things differently.
Let's talk a little bit about the URL though, because what I
Yeah.
was getting at, what I've always the what you describe as, let's say, the unique identifiers within the domain. Um, so what Mastodon and BlueSky are doing is that they're using a URI, which is non-colliding, by design, and then that URI points to the metadata of the client, which
So
enables, yeah.
BlueSky did, Mastodon did not.
Okay. Right.
Yeah.
Right. I'm
So
talking
that's
about, I read the BlueSky document. Right. Yeah. We'll circle back to Mastodon in a minute. But
mhm.
that's a very interesting design choice, to have a stable identifier for the RP. Because we always, in SAML land, we always had an entity ID for both the SP and the IDP. But then in OpenID, we sort of have a stable identifier for the OP because we have the
Yeah.
well-known configuration endpoint, right, and the metadata comes back. But there's always been this sort of gap for the RP where we had an identifier for the RP and SAML, but we don't in OAuth and OpenID. And I feel like this convention maybe fills that gap a little bit by providing a way for the client to provide a stable identifier and return metadata like a normal federation entity.
Yeah, and it's again, it's because most of the ways that OAuth and OpenID have been deployed have not needed that. They haven't had that constraint. Like it's okay for the authorization server to issue its own client ID and have it not be globally unique because it doesn't need to be globally unique. But as soon as you have the situation that we have with BlueSky, where there's client developers writing software that works with authorization servers that they don't know about ahead of time, now you kind of do need this global namespace of identifiers of the client software.
Hmm. So let's actually talk about Mastodon for a second, because you said they don't use this convention.
Yeah.
How do they handle the client registration ID identifier part then?
Yeah. So they use the more traditional older OAuth model of the authorization server is responsible for its own namespace of client IDs.
Hmm.
So as the first thing that the Mastodon app will do when the user logs in is ask for the server, and then the app goes and registers itself at that server to get
Sure.
a client ID. And that's before there's any user login part, right? So the client does a I actually think it's not even the actual dynamic client registration spec, but it's very similar to that. Of it
Mhm.
uses a client registration API to post up its metadata of client name, logo, blah blah blah, and then it gets back a client ID, and then it can start an OAuth flow like normal. So
Okay.
using the client ID that it got from that one server. So that means if an app is going to let you log into multiple Mastodon accounts, it might actually have to register at multiple different servers and have
Right.
multiple different client IDs internally.
Right. That was my next question you anticipated, which is what is the impact of that? Um, so okay.
Yeah. So this is where things start to get kind of messy. And because now you can imagine uh, a user downloads this mobile app from the App Store. And now you've got, 1,000 users doing that. And then each of those applications has to have its own client ID up to the server. So let's just say it's mastodon.social, like the big one, right? If 1,000 users download the app and then type in mastodon.social, 1,000 applications register for a client ID at that one server. So that
Right.
server now has to have 1,000 records of client IDs in it that it is keeping track of for doing OAuth flows.
Right.
So it works, it's fine. But then the problem is, let's say a user logs in and they're using the app, and then they like put the app away and don't use it for 2 months. The server still has this client ID record stored in it, right?
Right.
Of like because a user has logged into it at one point. So now you can imagine very quickly this problem turns into, we've got a giant database of client IDs to keep track of on that server. And it's
Right.
only ever going to get bigger because there's going to be more users downloading more apps. And if you get a new phone and download the app again, it's going to have a new client ID, right? So it's only ever going to get bigger. So it kind of becomes a problem of how do you just manage that many records of client IDs? And you will find issues on the Mastodon repositories describing this problem and trying to come up with solutions to it.
I saw there was one issue in particular that talked about client ID vacuuming. And so when you were on John's auth server, for example, when a client registers, it can request an expiration date, or the server could impose an expiration date. Because the client is sort of low stakes, maybe in this case, and so maybe you say, just flat out, this client's going to expire on this date. And I guess that Mastodon issue was basically going through and looking at at aged out clients or something. I don't know what vacuuming means. I don't know if that's a technical term or not. But
Yeah, I mean, essentially what they did is they decided, like, we're going to just delete any client records that haven't been used in a while. I don't remember what
yeah,
a while exactly is, but or how they determined whether it was used. But essentially it was just like, let's just delete old clients, right? So figure out what old is and then delete the records to clean up. So the problem there is that if the client isn't actually gone, and then it thinks it has a client ID that's been deleted from the server,
yes,
then there's an error, right?
right.
Because the client ID tries to use an invalid client. The client tries to use an invalid client ID then.
The app would
So
have to
that's,
handle that and know to re-register.
yeah. And the point is that, like, all of this is completely pointless because the client, the nature of open web clients is that there is inherently no actual identity of that client. Like the mobile app that gets downloaded from the App Store goes and makes a post request to this registration endpoint. There is no basis of any authority of the data in that post request. So there is no reason that the server should trust it. There's no reason that this request looks any different from this request that the same app makes or different apps make. There's just no basis of trust of the client. So there's no reason to even store the client data or to have a client ID referencing the stable information, because it wasn't like it meant anything in the first place. Like,
There's no
anybody can
policies
just,
on that were used on the
yeah,
client data. So what's the point of having it?
exactly. Anybody can just make a similar looking post request and get back a client ID. So what does it actually mean in the end? It doesn't mean anything, is the answer.
So client registrations can be an expensive operation for the IDP. I saw another issue in Mastodon about rate limiting the number of registrations per client, so you can't get DOSed on client registration. Um, and I'm not sure if BlueSky had to deal with that issue too. But any thoughts on like this is one of those first like in the wild massive or wide DCR. So any thoughts on that on avoiding DOS situations?
Yeah, well, I mean, if you think about, like, what it actually means is that in the Mastodon software, there's an API endpoint that takes no credentials of any kind
Hmm.
and writes a record to a database, right? It creates some identifiers like the client ID and a secret, writes some record to a database, which means there's just this open endpoint that does this. So that's why there's rate limiting problems and DOS concerns, is because
Yeah,
there's nothing stopping anybody from just hammering that endpoint and taking down the server, right?
right.
And again, like, that, the act of actually doing that doesn't provide any value to the rest of the system, so it's kind of pointless in the first place, and it shouldn't have really ever been needed.
Hmm.
But it was, so, and this is not to say that dynamic client registration itself is inherently bad,
Right.
because other applications of dynamic client registration avoid this problem by requiring that registration to carry some sort of provenance of the request
Like
along
a
with the
software
call.
statement.
Software statement saying that this, saying that, so that the server can say only my native app in the App Store can register for at this endpoint because it's
It's
signed
like
with
an
the thing
access
that
token
Apple gets.
for registration almost.
Yeah, some people roll it out with an actual just plain access token that is provisioned elsewhere. Like
Hmm.
you can imagine you can provision credentials through like MDM profiles onto
Right.
devices, and then they can go and use that in a dynamic client registration request. And now you've got now what it does is it means that dynamic client registration endpoint is no longer a public endpoint. Like it requires authentication of some kind, and
Right.
that's how you can kind of avoid this problem. But the point is that when it is a public endpoint, you have this problem where rate limiting and DOS are concerns, and it didn't even provide any value in the first place. So it's just this race to the bottom of trying to protect this endpoint.
Let me push back a little bit on the it didn't provide any value part, because um, part of the reason is that I would argue that we have trouble making policies about software clients. Like we're good at making policies about people because our access control tends to be very person oriented. But there are some useful policies we could make perhaps about clients. For example, Google and Apple have an integrity API that will give you an attestation that the app hasn't been changed, that the checksum's the same, or attestations about the type of hardware. Is this a rooted phone? If the
Mhm.
phone's been rooted, maybe all bets are off and you don't even want to let the phone register. Potentially, there's other interesting pieces of data, especially if the client has presented a software statement that allowed provisioning of certain types of claims into the client metadata. So I'm not sure that if it's like that it's not useful. I also would argue that if you want to have a cryptographic chain of custody from the app store to the device to the person that got authenticated, that actually that client identity is important. Um, I
No,
feel like
yeah. So we're saying the
yeah,
same thing. We're saying the
yeah,
same thing. So
yeah,
my statement was that if you don't do any of that,
yeah,
then the whole concept of the client registration is pointless.
yeah,
So yeah, as soon as you like can have some sort of attestation or authentication of the actual data in the client registration information, then it's useful again because you can make policies around it. But if it's just a public endpoint that takes arbitrary data in a post request and creates a client ID, that client ID doesn't mean anything and you can't make meaningful policies off of it.
yeah, yeah. I agree. If it's an anonymous registration and you can't assert anything about the origin of it, what the heck is it good for?
Right.
It's
Yeah.
really hard to argue with that. Yeah. Um, I want we could talk about this for more. I want to pivot a little bit to one
Well,
part. I'm sorry,
I
go on.
yeah, I want to relate this to BlueSky because I want to get
Yeah,
to the BlueSky's solution to this problem.
yeah. Go ahead. No, please.
Okay, yeah. So the BlueSky solution to the problem was to not use dynamic client registration. And again, the idea that there's some number of developers over here and some number of servers over here, and both of them don't know about each other on either end ahead of time, means we do need some sort of shared namespace of client identifiers if we want to um, be able to identify the software in some way to be able to eventually make policies on it, right? And what BlueSky did was the thing that has been done in many things in the past of using URLs to identify the software. This is something that you mentioned, like SAML has it, OpenID Federation has it, IndieAuth has it. It's a pattern that is actually Home Assistant does it also, which is kind of fun. Um, Same problem there, but the essentially the idea is there's a URL that identifies the client software, and URLs then are a shared global namespace. And what you can do with a URL is host data at the URL. So that URL then points to the client metadata, and the client metadata being name, logo, other attributes of the OAuth flow that the client might use. So that lets that gives you something to tie policies to. Now, I'm not saying that it's like a solution to only have trusted clients because it's not. But what it does do is it means that one, you don't have a public endpoint where anybody can just create entries in your database anymore. You do have an OAuth endpoint that can take an previously not seen URL and maybe register, keep some data internally about it. But you can do a lot more to like throttle and protect that in a way that's not just trivial rate limiting. And it's also more expensive for to spam that endpoint, because you need to be able to create arbitrary URLs, which has an actual cost of domain registration.
Right.
So that's like, it's a fundamentally different model of using this shared global namespace of URLs to identify client software.
It sounds like you're talking about that let's just call it the AS, the authorization server in this case, can maybe have certain domains that it trusts. Um,
Sure, yeah.
so is that kind of what you're talking about? You can sort
Yeah,
of
so
build a trust model like this.
you could go that direction. Yeah, if you want to be like totally in the open web, public web, then you need to accept arbitrary URLs that you've never seen before.
Hmm.
Um, but once you can imagine, you can very quickly start to actually build some sort of history of these URLs. Like, let's say there's a very popular client that a lot of your users use. As soon as like 100 people authorize that client,
Yeah.
and it has some history of behaving well, then you can flag that as like, oh, this is a trusted client, or any client in this domain is trusted, and then you
Right.
can
Or
start like,
any .mil or
right, yeah,
.edu.
totally, things like that. You can start doing a lot more, because the DNS system gives you some level of provenance of the client data. So that's where you can get very creative with the policies, like you're talking about, of like how you trust them, how much friction you add to the flow to get users to click through, to be like, no, really, I do want to use this untrusted client that you've never seen before. Um, Things like that. Yeah.
One aspect of the BlueSky design document that I really liked was they were quite clear. We're not using shared secrets. You're not getting back a client secret. Um, and they use some advanced features that I really like. You're doing private key authentication. Um, they are specifying Depop with mandatory server issued nonce to bind tokens to specific software clients. Um, and they're using pushed authorization requests to streamline the request flow. This, can you comment on some of the design? Is this one of the most advanced sort of OAuth federations you've seen?
Yeah, this is kind of the fun thing about OAuth, is that it's very much choose your own adventure when you're kind of building an ecosystem from scratch. There's a lot of different OAuth building blocks you can grab and assemble, and they've essentially chosen a lot of the more advanced and higher security options available, which is great to see. And from makes a lot of sense from their design goals. So like client authentication, again, with a registered client of some sort, you could use the simple client authentication of a client secret, but that's a shared secret, and shared secrets are generally not as good as
We've been trying to
semantic
get rid of
secrets.
shared secrets for clients since like 2000. Yeah.
Yep. And one of the other nice things about doing this client metadata, hosted metadata, is that if the client is actually on a web server, it can have a private key on the web server and publish the public key in the client metadata. And now you've got a really strong client authentication between servers that have never before talked to each other. So that's a very cool attribute you get out of it. Um, Depop is a good idea in general. Depop is the idea of the access token itself is no longer enough to use the access token. So if access tokens are stolen, they can't be reused, and it works by each client instance having its own private key, which is different than the client like registration. So in in this world of like a mobile app, each mobile app would generate its own private key, and that's not part of the client metadata that's hosted at the URL. It's just used in Depop to bind the access token to that instance. So
Is it
that's
an
cool.
ephemeral key or is it
It's
it's
not
used just for that
necessarily.
token transaction, or is it used once and it's used for all tokens?
No, it's not. It's used to actually bind the access token to that instance
Hmm.
ongoing. It's not only part of the like getting the token. So it's actually part of using the token on an ongoing basis.
Right. And I
So
asked this question, and Glue supports like Depop, but it's not the most used feature out there. And it's still sort of a new feature. It just went standard. It hasn't been standard all that long, so we haven't seen that much adoption in the wild. So it's interesting to see them use it.
Yeah, and that's kind of the benefit of like, they're building a new OAuth implementation, like a server implementation, so they can kind of set the rules. A lot of people are plugging into existing OAuth implementations, like if you're using, any of the off-the-shelf OAuth servers in your, and you expect people to have client developers, lots of client developers use it, then you kind of want to go down a couple notches in terms of features you're asking them to implement so that it's easier at the expense of it being less secure. So um, the it's I think it's a interesting choice that they've like cranked the security knob up so high.
Yeah.
I
Um,
like it.
And so one issue about this client discovery is that it doesn't really work with mobile clients because you can't make a request back to the mobile client. You might need some type of server backing for that client. And then I saw in their notes that they had mentioned that it's possible for mobile apps or browser-based apps to coordinate with a token mediating backend service and for the combination to form a confidential client.
Mhm.
Um, and they mentioned something mobile apps and browsers apps can also adopt a backend for front end or BFF architecture. So the mobile app has a BFF that's running in the cloud with a stable URI. Any thoughts on
Yeah.
that design?
Yeah, so both of those things are actually mentioned in the OAuth spec I've been working on, OAuth for browser-based apps. It is very nearly final right now. There's a handful of feedback I need to respond to from the one of the last calls. Anyway, that document is well worth a read. We'll make sure it's linked in the show notes. If you are writing a single page app or JavaScript app for the web, it goes through more information than you ever knew you wanted to know about the security model of using OAuth in browser-based apps. But it does lay out these patterns, these options of having a full backend behind your JavaScript app where everything is proxied through, including all API requests. And then that sort of middle ground is the token mediating backend, where the backend is only responsible for the acquisition of the tokens. And then the tokens are the single page app makes API calls itself using the tokens later. Um, there are trade-offs to both models, so it's worth reading the doc. And both architectures apply with mobile apps also, although the security models are completely different with mobile apps, but you can still apply both models to mobile apps as well. Um, the main idea there is like, as soon as you can do more of the communication with the actual API on the server, you can use better client credentials because they can be managed on the server that you're running. The downside, of course, is that if you're, especially with mobile developers probably don't want to run a server themselves. That was kind of the reason they did it as a mobile app. Um, but there is one more sort of in between scenario for BlueSky specifically with this metadata document, which is that, and again, it's very common that mobile app developers will have a website for their application so that users can find their app and they can link to the app and find information about it. Um, that website can host the metadata for the app. So it's just a JSON file, right? It's like not a big deal to put a JSON file on a web server. It doesn't change, like the metadata for the app doesn't change. That's just where the name and logo and stuff is hosted. You obviously can't have credentials like a public key for that mobile app, but that's fine. It's just a public client then. But that's a way you can deploy a BlueSky mobile app, still use the client metadata hosted at your app's website, and everything still works fine after that.
And is there an impact to asymmetric client authentication there?
Yeah, you would not be able to. I mean, this is inherently a problem with mobile apps, is that you can't put anything in the mobile app in the App Store bundle that is a credential, because it'll get copied to everybody's phones and then anybody can extract it. So then
Sure.
it's not really useful anymore. And that applies regardless of the type of client registration you're using, whether
And
it's
it applies to
pre-registered or,
browser-based apps too and mobile apps. Yeah.
yeah, same thing.
Yeah.
There's actually a comment in here about this in the chat. Isn't it possible to issue a certificate to each client and then use the certificate at the authorization endpoint? So yes, like that is a possibility. And I was kind of hinting at this with something I mentioned earlier. Like if you have the ability to provision a certificate to each client out of band, like ahead of time, then yes, absolutely you can use that. But you don't have that ability in the public app store model. Like there's no way to do that. If you're doing MDM deployments of your apps, then you do get a way to like provision certificates down to the apps be like outside of the app code bundle. And if you can do that, then yeah, you can use that certificate as client authentication in a couple different ways. But there just isn't a way to do that for pure single page apps or mobile apps in the app stores.
So you can't distribute a private key or a secret into a mobile app or browser-based app, but couldn't a mobile app generate a private key, a key pair on the fly, and then send, instead of using a JWKS URI, just send the key store itself as part of the registration request, so it could still use asymmetric authentication?
Yeah, so you can absolutely do that and use dynamic client registration to establish that that credential. If you're doing that with dynamic client registration, you still have all the problems with dynamic client registration, and because again, it's
Sure. Yeah.
the key is previously not known, so there isn't really any like future requests get tied back to that instance, but the first request is still public unknown. So there's no provenance of the data. However, if you do this with the non-dynamic client registration version of it, you're essentially describing depop of the app makes up a key and then uses the key in every request to the OAuth server and the API, which that is what depop is.
Mm-hmm. Okay, we're a little behind on time. I'm just going to ask. I'm going to put you on the spot and ask one quick question, and then we'll go into last thoughts. So, both Mastodon and BlueSky want to achieve sort of this decentralized, network. Um, do you think that they've achieved that? And having attended a very sort of open source oriented conference at FOSDEM, the Mastodon community seems to not really trust a venture backed owned BlueSky, let's say, because their theory is it could always be sold to an Elon Musk, perhaps, and then all of those things go out of the window. Do you think that the design of this system protects the corruption potential from a new acquirer?
Yeah, I mean it's a tough question. So here, I guess I want to push back on that concern by saying Mastodon isn't actually that much better in that most people in Mastodon are on mastodon.social, which is one server. The Mastodon software itself is managed by a company, and that company could be sold. And if Mastodon, the software, is sold to somebody, they could change it and make it do whatever. Now, yes, it's open source. Someone can run a fork of it, and you can keep running your own bubble over there. But for all practical purposes, if the Mastodon company or software is sold to somebody, it would destroy the network. Like there is not a way to. It's not actually resilient to that. Is my point.
And what about not comparing them, but just looking at BlueSky? Do you think the design of this federated system is that somehow the goal of this, which was to liberate ourselves from the the uncertainty of a corporate owner, have they achieved that through the protocol and the design? Because Twitter is just like a domain, a realm owned by one person, but BlueSky is a protocol and there's an architecture and a design. And I'm wondering if you think that design actually protects us, even if there is a change of control.
Architecturally, I think both Mastodon and BlueSky do achieve that. Practically, whether it would survive that kind of event is a different story. But yes, like theoretically, both of them can survive any one entity taking over the control of the software or of the server. Again, like for practical purposes, that's not actually true. But but from a protocol perspective, I think both of them are, there's different solutions to it, and there's trade-offs on both sides of concerns about the actual federation between them and how things are handled. But yeah, like theoretically, they've solved the problem. Emphasis on theoretically.
Right. Last thoughts, Aaron? Anything you want to promote? Cool stuff you're doing?
Yeah, I mean, definitely take a look at a lot of the new work coming out of the OAuth working group. Go to oauth.net/2, and there's a link to a bunch of recent RFCs, new work coming out. There's the browser-based app spec that I'm working on that's nearly done. There's a resource server metadata spec, which we didn't even get into in this, but
Hmm.
is potentially relevant to as a solution to Mastodon's client registration issue. Weirdly enough, um, so lots of interesting work coming out of the OAuth group. And yeah, follow me on Mastodon or BlueSky or LinkedIn if you want any updates about any of the stuff as I'm continuing to work on it.
Right. And I did have a link to the resource metadata. Yeah, we did not have a chance to get to that. 40 minutes went pretty fast. I will add a link to Depop. There was Alan asked for that from the stream, and I'll add a link to the browser-based OAuth draft, which
Great.
we're looking forward to. Awesome. Okay, with that, I will say, well, let me just announce the next episode. Actually, next Tuesday, it was supposed to be Daniel Fett, but he had an unexpected conflict. So we're moving him back to July 17th. So actually, we're off next Tuesday. You're off the hook, no live stream. Next Thursday, we're going to welcome two veteran integrators to talk about sort of lessons learned from some of their IAM projects. So I hope to see you next Thursday. Thank you so much, audience. Thank you so much, Aaron, for joining us again. It's a two-time Identity, and we'll see you next time.